In this exercise we move on to image fusion, specifically looking at hybrid data first of all. The hybrid data normally means this was data acquired on a hybrid scanner such as PET-CT, PET-MR or SPECT-CT, such that the images have the same geometry even if not the same image dimensions, the image matrix or slice thicknesses. And in the case of data from a hybrid scanner, the fusion workflow is actually reduced to a fused display of each modality, which brings you quickly to the VOI analysis step. So for this we'll use the FuseIt tool, and the matching workflow in the FuseIt tool is actually broken down into 5 major steps. These can be seen in the list of pages in the top right. So we have loading of input images, reference and matching, the inspection of the matching result, image algebra, and then finally VOI analysis. So when you're analyzing hybrid data, it's useful to set the hybrid workflow as the default, and this we can do in the FuseIt configuration. This is accessed from the configuration icon in the lower left next to the FuseIt menu, and we get a dialog where we can see various settings that will affect processing in the tool. So you can note that in this configuration we have the default color tables, the default parts of an image pair that will be used as a reference, and then here we have the default matching mode that will be used. So for this exercise we can change the default matching mode to hybrid. So with the hybrid workflow now set to default, both the input and the reference image can be loaded together. And this is most effective from database or DICOM, where the series modality is clearly identified. So now for the exercise, we can go to the DB Load tab. Here we switch to the demo database and we'll search for the subject PSEG2, which is our whole body PET-CT example. And from the series available for PSEG2, we can select the original PET-3D and the original CT. If we scroll to the right, we see that these images have the same number of slices in the Z direction, but have a different resolution in X and Y. And the FuseIt tool will deal with this for us to work with the images in fusion mode. When you click Open, FuseIt will load the images, select the hybrid workflow, reslice the PET to the resolution of the CT, and then jump to the Comparison tab to display the alpha blended fusion of the series in the whole body layout. In the top right, the image controls are identical to what we've seen in the View tool, but when there is fusion functionality available, there are actually 2 copies of the image controls. Here we see A and B, color-coded with green and blue icons, green for the input data, blue for the reference data, and then we have an additional set of fusion controls below those image controls. So the new slider below the image controls adjusts the alpha blending between the input and the reference images. And on the right hand side we have a shortcut that will take us between 0, 50 and 100% settings to show entirely the input image, a 50-50 fusion, or entirely the reference image. In the lower right we have additional controls to choose the images that will be displayed in case more than 2 are available. We have layout shortcuts and we have a capture shortcut. Here we see the choice of input and reference series, shortcuts for image display, at the moment we're on the whole body display, and then capture icons to capture the display for presentation. To perform VOI analysis in fusion mode, we can jump to the VOIs page using a shortcut on the right lateral taskbar. Note that here there are also two sets of image controls in the top right, as well as the fusion controls. And when we're using threshold-based VOI tools, it's essential that we have the appropriate set of controls activated. So if we're trying to set thresholds based on the PET data, we should have the A set of controls for the input data activated. The MIP display can be configured for the input and the reference separately. Here for the PET data, we can use the common inverse grey color scale, and this will give us navigation through the image. If we then select the B reference set of image controls, we can in parallel turn on the MIP for the CT, where we mainly see the skeleton. Now, to finish off this exercise, we'll use the oncology hotkey VOI methods to create some VOIs. So we can select the input set of controls, we see the MIP for the PET, and we can use the MIP to find the lesion near the heart. Then we can zoom into the rest of the image display using the controls below the image, so that we see the lesion more clearly. We can use the fusion slider on the right hand side below the image controls to see how the uptake in the lesion corresponds to the anatomy on the CT. And if we want to, we can select the reference image controls and adjust the display for the CT so that we see, for example, the lung anatomy more clearly to examine the fusion effect. And make sure to switch back to the input controls. Then I can make sure I'm well triangulated on the lesion and use Control L to create our automatic isocontour based VOI around this particular lesion. And then again we can use the fusion slider to see how that contour corresponds to the PET data or to the CT anatomy.